Alright, so today I'm going to do a very quick video about how to use a multimeter. Now you might hear some people call this a voltmeter or amp meter or whatever. The reason this one's called a multimeter is because it can measure multiple things. I know I'm getting some reflections here, but I'll make sure that I show you the symbols that I'm connecting to. So a multimeter, it has these ports at the bottom. You need to pay attention to the ones that have, for the first few that we're doing, you have V, the ohm symbol, diode, and the capacitor symbol. So you're always going to put the black one in the black port. You can actually see here. So the black one goes in the black port. The red one goes, in this case, in the V one. I'll show you the other one in a minute. So I've got a few different devices here that we can measure. The easiest one to show first is a resistor. So that's this. So we're going to switch our multimeter on, and we're going to put it on the ohm symbol or omega symbol, which is the symbol for resistance. So then we're just going to take our two leads here, and actually if we touch them together we can see that there's like basically no resistance. If we touch either lead of this resistor, we can see this is 215 ohms. I believe this is a 220 ohm resistor. It's just a cheap one. Okay, so yeah, that's and you can do this either way. It doesn't matter. You can hit the red on the left and the black on the right. It doesn't matter. So the red is your positive, I guess, and your black is your it's your common or your ground. So all right, so that's a resistor. So let's move on to the diode selection, which is the next one over. So this is a diode. You may be able to see that there is a white line on the end of it here. You'll either see it as a white line on diodes like this, or you'll see it as a black line if the diode is like red and made of glass. There will always be a line that kind of indicates the polarity of it, or the direction that current flows through that diode. So with a diode, you want to make sure that when you're verifying that this is actually still a good part, you want to make sure that current can only flow in one direction. So if we put the two leads on here, I'm putting the red one, or I'm putting the black one on the line side and the red one on the other side, and you can see that there is a voltage drop across this of 0.189 volts, and that's good. That's certainly within the range of the voltage drop for this. But then if we swap and we put the black on the red on the line side, we can see that it still says OL, and that means just open. It's just an open circuit. So that means that there's no current able to flow the opposite direction. So that means this is a good diode. And now this is a ceramic capacitor. It is not polarized, and you might hear some noise because I actually just realized I need to pull out a polarized capacitor to show you the difference. So there's a polarized capacitor. That is an electrolytic capacitor. And you can see that this one actually shows you very easily to read that it's 100 microfarads. So let's actually start with the polarized one. The leads are a little bent here. So for the polarized one, the positive side is this longer leg. There's also a white marking that shows you the negative side. So we're just going to do that. And actually, let's swap it. I might need to do this the other way. Huh. This one's not working well. So let's actually, I'm going to show you something different. Let me switch to some different leads that you can usually, they didn't come with my multimeter, but I find them super useful. So let me just plug these in and then I'll show you what they look like. So these are little hooks, so you can grab leads really easily with them. So let's grab these instead. There we go. We just weren't getting a good connection before. So this is rated as 100 microfarad, and look, man, it's spot on. Wow. That's actually really impressive, because this is some like giant combo pack of capacitors. Anyway, let's move on to the ceramic capacitor. This one, it does not matter which direction you. Whoops. It doesn't matter which. All right, I'll just hold on to it. It doesn't matter which pin you hook the positive up to, and you can see this one is a 1 nanofarad capacitor. So if it is below the rating, usually like capacitors will fail and they'll go low. So if it's below the rating of, oh yeah, this is the capacitor symbol. If it's below its rating, that means it's dying, and just don't use it. Use a different one. So now we're going to test voltage, and I actually noticed when I pulled this battery out that it's got some corrosion on the terminal here, the negative terminal. So let's take a look at this one. Let me switch back to my other leads, because they're just going to be a little easier to use in this case. Or probes, I guess is what they're called. So this is a 9-volt battery. It has positive marked as this terminal, negative as the other one. If you're on like a AA or a AAA battery, it's going to be the pointy end is the positive one, and the flat end is the negative. So we're actually going to switch our mode over to the V with the line over it, not the V with the sine wave over top of it. This is for AC voltage, and this is for DC voltage. If you are watching this video and you're very new to multimeters, I do not want you to use this to measure AC voltage. Just get a little bit more comfortable with DC low voltage stuff first, and then you could try that. I don't, just please be careful. I don't want anybody to get hurt. Okay, so we're going to touch the positive with the red and the negative with the black, and we can see this 9-volt battery is putting out 6.541 volts, which it is definitely dead. So yeah, that's a good way to test out your batteries, and I recommend you just try this out on a bunch of batteries. You'll find that your rechargeable, like nickel metal hydride batteries, if you have like Eneloop or something like that, that those will be 1.3, 1.2 volts instead of the 1.5 that you normally get out of a AA. So this is going to go in the trash. Or if you have battery recycling in your area, please do that instead. So then now we're going to measure voltage. So voltage is measured across a device that already has voltage running. So I've got a USB micro USB port hooked up to this breadboard. The ground is connected to this Arduino, but the positive is not connected to the Arduino yet. So it's not actually going to get power. It's just going to be an open circuit, because you can see these two wires are the positive, and you would have to touch those together to complete the circuit. So we're just going to use this to measure voltage. So I've got my USB power supply here, and I'm going to plug this in, and then I'm going to measure the voltage that this USB power supply is giving us. So I'm going to touch the VCC and the ground, and I might need to like get through the. Sometimes the flux on here is tough to get a connection through. There we go. So we got 5.18 volts DC. And if you swap these, if you hook the negative or the black up to the VCC or the plus 5 volts, and you hook the red up to the negative or the ground, you'll get negative voltage. And that just tells you, the negative tells you the polarity that you've swapped these around. All right, and now we're going to measure current. So that's this over here on the right is the two current measurements. So what we're going to do is go over to the current with the flat line on it, because we're measuring DC, not AC, and we need to move. I'm going to switch probes here because it'll just be easier this way. So we're still going to plug the black one into the middle, and then we're going to plug the red one into this A side here. This is for measuring amps. And measuring this is different because you're not just measuring it across something. The multimeter has to be in the middle of the circuit. So we've actually got this open circuit here with these two wires sticking out here. So we're just going to connect to one of them, and then when we connect it to the other one, it actually does the power. I should probably plug this in after I connect this, but there you go. So now we are powering our Arduino. I don't even know if I have a program on here. Yeah, I've got something on there. It's not going to do the blink like it would normally do. Anyway, you can see that it's negative because I hooked them up backwards. But we are getting 0.019 amps DC. And so this is 19 milliamps. So if you move the decimal place over and you get to milli, so this is 19 milliamps. So this is an Arduino. It's pretty low power. You can I definitely think it'd be cool to try this out with your Raspberry Pi if you have one of those. See how much power it's drawing. It's a very useful tool for determining how much power you need to provide a device over time. Like if you're going to battery power something, you need to do this calculation, figure out how much power is it drawing, how many amps is it drawing. You know the voltage, it's 5 volts, so you can figure out the power, and you can, if you're looking at milliamp hours, like a battery, like a rechargeable battery is rated in milliamp hours, and so you can say, oh, it's 19 milliamps. If this thing is 2,000, this, I don't know, portable battery pack is 10,000 milliamp hours, you can do that calculation to figure out how many hours that this device will run on that battery pack. So anyway, that is the, I've shown you basically everything. I have not touched the AC variations of these, and I have not touched any of these here. So hold, actually, I can show you real quick. So if you press hold and then you disconnect this, it'll just hold that value on the screen. That's it. And then if you press it again, it'll update again. There's like min, max, and range and things like that. I'm not going to do that right now. And like AC, you can measure the frequency of it with this hertz button. But yeah, that's basically it. If you want to learn more, just look in the manual of your multimeter, or look on some more detailed tutorials from somebody who maybe knows more about what they're doing. But yeah, I hope this was helpful, and I hope you have a good day.